Hi, I'm Katie. I'm a PhD student here at the University of Glasgow, which means I've done my degree here and I've stayed on to do additional research. I'm going to show you how to do a titration to figure out the concentration of an unknown acid. Before I start, I'm first going to tie my hair up, put my safety specs on and put on my gloves, which is standard practice before any experiment. First, I'm going to wash the pipette. I do this by attaching it to the pipette filler, taking up a small amount of ethanoic acid. When attaching the pipette to the filler, it's important to hold the glass pipette at the top near the neck to make sure that the pipette itself doesn't get broken. I'm removing the filler and holding my finger over the top and twisting upside down and emptying into the waste while spinning. Now I have cleaned the pipette, I'm going to pour ethanoic acid into one beaker. From this beaker, I'm going to take up 50 ml with the clean pipette and deposit it into a different beaker. To this beaker, I'm going to add 50 ml of deionized water. Using a plastic pipette, I'm going to add 5 drops of the indicator phenolphthalein to the beaker. I'm now going to add the stirrer bar to the beaker. This is sometimes called a flea. I'm now going to put the beaker onto the stirring plate and turn it on. I only need to let it stir for a few seconds. Now I'm going to set up the burette. First, I'm going to pour out the sodium hydroxide solution into a small beaker. Now we are going to wash the burette. I'm going to make sure that the tap is definitely closed. Now I put the funnel into the burette. I pour in some sodium hydroxide solution to make sure that the burette is only half full. I open the tap to make sure that the sodium hydroxide moves through and there are no bubbles left in the underside of the tap. The remaining solution, I will wash out the top into the waste bucket. Now to fill the burette, I make sure that the tap is again closed. Add the funnel back to the top of the burette and pour in more solution than is needed to fill. I now open the tap and watch the meniscus fall till it reaches the 0 point and close the tap. Before I start the reaction, I check the burette to make sure there are no bubbles. I now put the stirrer plate and beaker under the burette. I take down the starting volume on the burette in my lab book. Now I lowered the burette so it is at eye level. I turn the stirring on gently just so that there is a continuous stir. Now to start the reaction, I open the tap slowly and allow the sodium hydroxide solution to drop through 1 drop at a time. Throughout all of this, I keep my eyes on the colour changing flask. Each drop of sodium hydroxide causes the colour to change to pink. This quickly goes back to being a colourless solution. The reaction is complete when the colourless solution stays a light pink. Now that the reaction is complete, I will record how much sodium hydroxide has been used. I do this by lowering myself to eye level and reading from the bottom of the meniscus on the side of the burette. For this titration, it has taken 4.5 centimetre cubed of sodium hydroxide solution to cause the colour change in the indicator. My lab partner Lucy will now take you through the science of this experiment.
Thanks, Katie, for a great demonstration of a titration. I'm now going to talk you through the science of the reaction that you've just seen. The titration you just saw is a reaction between an acid and a base. Acids have a pH of less than 7 and have more H+ ions. Bases have a pH of more than 7 and have more OH- ions. Here you can see some acids and bases you might be familiar with from school. So the pH is a measure of the amount of hydrogen ions in a solution. Acids have more hydrogen ions, so have a lower pH. Water is neutral and has a pH of 7. Acids and bases react in neutralization reactions. This is where the H+ and the OH- ions react to form water. In this titration, you're reacting ethanoic acid and sodium hydroxide according to this equation. We're doing this titration to find out the concentration of the ethanoic acid. This is the apparatus we need to carry out a titration. We need a conical flask, or in this case a beaker, a pipette filler, and a burette. Indicators will change colour when the reaction has finished, when it's reached its end point. In this case, we use phenolphthalein, which changed from colourless to pink as we went from an acidic solution to a basic solution. Doing a rough titration first helps us know the approximate volume of solution that we'll need to do the titration. This helps us know how fast to add the solution from the burette. After our rough titration, we do 3 more titrations and take an average of our results. We also need to make sure our results are concordant. This means that the values are very similar to each other. It's really important to read from the bottom of the meniscus when at eye level, and also to add the solution dropwise from the burette. Keep your eyes on the beaker because the colour change will happen very suddenly. As we can see in this equation, 1 mole of ethanoic acid reacts with 1 mole of sodium hydroxide, so our ratio is 1:1. This means that at the end point, the number of moles of ethanoic acid will be equal to the number of moles of sodium hydroxide. The concentration of the sodium hydroxide was 0.1 moles per litre. So using our equation, moles equals concentration times volume, we get that the moles of sodium hydroxide was 4.5 times 10 to the minus 4. Because it's a 1:1 ratio, this is also the moles of our ethanoic acid. So rearranging our equation, we get a concentration of 0.009 moles per litre.
I hope you enjoyed that experiment. The colour change is really interesting to see, and the skill itself is really useful throughout your entire chemistry degree.